So this session I'm doing basically a review of arithmetic, but before I did the arithmetic part, I wanted to talk about the different sets of numbers because understanding that the terminology is really important so that you know kind of what you're looking at and everything. So sets of numbers. So we categorize numbers into, based off of their properties. And so the first set of numbers are what we call the natural numbers, and we use this symbol that's an N. It's a special N with like a double line in between there. These are also called counting numbers because these are the numbers that you start with when you start counting. You start counting at 1. And these are called natural numbers because these are the numbers that people start using naturally. Back when people started coming up with names for numbers and all that stuff, they always started basically at 1. So that's why those are called the natural numbers. When we include 0, that's where we're talking about whole numbers. Now notice that in layman's terms, like in everyday terms, we'll often refer to negatives as being whole numbers, but technically negatives are called integers because technically the mathematical term whole numbers refers to just the positive numbers. But you'll hear me call negative numbers whole numbers, and it's used every day. It's just it's just an understanding that basically it's just the negative version of the numbers. And we've got the set of integers. So as I mentioned, the integers, those are the whole numbers and then their negative counterparts. So that's where we start involving the negative numbers. Then numbers that can be written as a ratio of two integers, which basically means numbers that can be written as a fraction. Those are what we call rational numbers, and that symbol is Q. And I should say that the symbol for integers is Z. So the symbol for integers comes from the German word for integer, and the German word starts with a G or a Z. So that's why that is a Z. For rational numbers, the symbol is a Q because it stands for quotient, because quotient is basically what we call a fraction. It's another name for a fraction. So when we say we've got rational numbers, we use the Q because these are all numbers that we can write as a fraction. And basically, if the decimal ends, which means it's a terminating decimal, or it repeats, it has a pattern that repeats, it is a rational number. Any decimal that does not have a repeating pattern or does not end is an irrational number. So the set of irrational numbers are, which this textbook uses H for. There's not really a good symbol that's usually used universally for irrational numbers. I'm not sure why they use H, but this textbook uses H. And these are just numbers that you can't write as a fraction. So every number is either a rational number or an irrational number. There's no overlap between those two categories. And irrational numbers, usually most square roots are irrational numbers. If you take a square root of a number and it's a decimal, it's automatically an irrational number. Pi is another example of an irrational number because that's one that goes on forever. And then when we combine everything together, rational and irrational numbers, that gives us the real numbers, which we use the symbol R for. And basically, any number that we work with, we call is a real number. So it's kind of best understood with this. It's sort of like a Venn diagram. It's just instead of things overlapping, they're like inside of each other. Basically, every number is a real number. And then you can divvy up the real numbers as either irrational or rational. So there's kind of like no overlap between these two categories. Then you have numbers that are rational numbers, and then they may not be integers, whole numbers, or natural numbers. So these are just like fractions are rational, but they're not in the other categories. But you do have numbers that are in these inside categories, and they are also in the outside category. So they're kind of inside out. So like the number 1 is a natural number, it's a whole number, it's an integer, it's a rational, and it's a real number because it's inside all of these other categories. So you kind of look at your numbers inside out to determine where it fits. And this is, you want to put it in the most inside category if possible. And then if it doesn't belong there, you kind of work your way out, and that's how you kind of categorize your numbers. But numbers can fit in multiple categories because of the fact that these are sort of embedded in. So here's what you guys are here for, is reviewing arithmetic. And particularly, I'm going to focus on negative numbers because people really struggle with negative numbers. And understanding how those work is really important because we're going to be working with a lot of different numbers going forward. So we have basic rules, and it all determines if they have the same sign or a different sign. So a same sign would be if you're adding two positives together, or if you're adding two negatives together. So if two numbers have the same sign, like for example, we have 2 plus 5, or maybe we have -2 plus -5. Those are examples where we have the same sign. You take the numbers and you ignore the sign basically, and you add them, and then your answer has the same sign as the original numbers. So 2 plus 5 gives us 7. And when you add a -2 plus a -5, that gives you -7, because 2 plus 5 is 7, but they're both negative, so your answer is negative. So that's how you add numbers that have the same sign. Now, if you have different signs, it's actually a little bit different. So let's see if we had like a -2 plus 5, or maybe if I had a 2 plus -5. So these are the two kind of possible combinations here where they've got opposite signs. One's negative, one is positive. So to figure these out in your head, I mean, you could just put this in a calculator, but it's also good to be able to do this mentally, because if you can do these quickly in your head, it saves time for other things that are more complicated. So you basically are subtracting the numbers, and then the answer gets the same sign as the bigger of the two numbers. So with -2 plus 5, you subtract 5. You would do 5 minus 2. You do the bigger number minus the smaller number. 5 minus 2, which is 3. And then because 5 is positive, your answer is positive. So in the other case here, if you have 2 plus -5, you would still be thinking in your head 5 minus 2, which is 3. But because 5 is the bigger quantity and that's negative, your answer is going to be negative. So that location of the negative sign makes a huge difference on the sign of your answer. And you really have to pay attention to the signs of all of your numbers that you're adding to make sure that you are doing the addition correctly. Are there any questions on adding these numbers?
I don't have any.
Okay. I don't see anybody else chatting. So we'll move on to subtraction. This is where people really get confused. So basically, when you're doing subtraction, it's easier to turn it into an addition problem. And this is because subtraction is defined as adding a negative. So if I could have -2 minus 5, or I could have a -2 minus a -5. Let's see, we could do a +2 minus 5, +2 minus -5. These are like the 4 different combinations that you can have when you're subtracting things with positive and negative signs. So it's easier to, because subtraction is defined as adding a negative, you can rewrite these. So like -2 minus 5 becomes -2 plus a -5. And now we know how to do that because we just did that on the previous slide, because now you're looking at your rules for adding, and that gives you -7. I should have given myself a little bit more room here. And if I skip down to the third one, 2 minus 5, you can think of that as 2 plus -5. And we saw that on the previous, that was -3. Now, when you're subtracting a negative, this is where it gets a little trickier. And actually, I'm going to kind of move this over so I have more room. Same thing here. Oops, and that was a +2. So when we are subtracting, and we're subtracting negatives, so first off, that first subtraction symbol becomes adding a negative, and then we have our number that we are subtracting. So it would turn into a -2 plus, and then a -5. Now, the negative symbol also means the opposite. So if you have a negative in front of another negative, it's just saying what is the opposite of a negative number? And that's a positive number. So this becomes -2 plus 5, which I didn't give myself enough room here. That is equal to 3. So the same thing happens on the 2 minus a -5. So basically what happens is if you are subtracting a negative, it turns into an addition problem. And I've seen some people kind of take this and turn it into a plus like that to kind of remind them that if you're subtracting a negative, it turns into addition. So this would end up being 2 plus 5, which would give you 7. So you want to be very careful with the subtraction, and in a way, the subtraction symbol and the negative symbol are the same thing because subtraction is adding a negative. So you can interpret them either way. They're basically equivalent ideas. And then they also mean that you're kind of doing the opposite. So subtracting a negative is the same as adding. If you're subtracting a positive, treat it as you're adding a negative versus adding a positive. And that can help you keep track of what your signs are, because people do get really confused when they start subtracting, especially when negatives are involved. Are there any questions?
All good here.
Okay. Now, multiplication and division, and these are actually a lot easier to work with than the addition and subtraction when you deal with negatives. So they use the same rules, and that's partly why they're easier to work with, is the rules that apply for multiplication also apply for division. And the whole idea behind it is that if you have two negatives, they become a positive. So what this means is if you have a negative times a negative, it gives you a positive. Or if you have a negative divided by a negative, you get a positive. If you only have one negative, like a negative times a positive or a positive times a negative, it stays negative. Because that negative, basically the two negatives cancel out, like the opposite of a negative is a positive. So that's basically what's happening here. So the general idea is to count how many negative signs you have when you're doing multiplication and division. And if you have an even number, your answer will be positive. If you have an odd number, your answer is going to be negative. So if I have a -2 times a -5, that gives me a +10 because the two negatives cancel out. If I had a -2 times a +5, there's only one negative sign, so my answer is still negative. And even if I flipped where that negative was, I would still get a -10. And then if I have two positives, that gives me a positive. So you need to, the negatives kind of get paired up, and that's how they determine whether it's going to be a positive or a negative answer. And notice how I've written all these multiplications with parentheses. So the one thing that once we get into algebra, you never use the x to show multiplication. And you should never use that in your work because x is used as a letter, as a variable. So we never use an x for multiplication. So you can either put them in parentheses like I did here, or you can put like a dot in between them because now the dot is what we use for multiplication. But never use that x because then it's going to get really confusing down the road when we have other things going on. So I'll move on to absolute value here. So this is another thing that people get confused about is working with things that have absolute value. Because people get confused and they think that it's like a parenthesis when it's not. So absolute value is basically asking for a distance between the number and 0 on a number line. So if you were to graph it on a number line, how far away is it from 0? Distance is always a positive quantity. We never tell someone that I want -5 feet or something like that. Distance is always positive. So the absolute value always makes things positive. And our symbols are vertical bars, so they're just bars straight up and down, and they're not parentheses. So when you're showing your work, when you're doing problems, you want to make sure that your parentheses and your absolute value signs look very different because they're not the same thing. And absolute values behave differently from parentheses. What this means is you can't multiply something outside of the absolute values by something inside. You can't multiply across the absolute values. So I'm going to just write that down. You can't, I guess you can say that you can't distribute or multiply something outside the absolute value by something inside. So they're not exactly the same as parentheses. What we have to do is we have to basically take the absolute value, which means whatever's inside becomes positive, and then you can work with your multiplication or what else you're doing. There is a mathematical definition here for absolute value, and that will be used when we later on in the course when we're solving equations that use absolute values. So we will be solving absolute value equations, and we'll be using that definition later on, but you don't have to worry about it at this point. So I have just pulled out, so if you are not aware, and in my video about the introduction to Alex that I did on Thursday, I kind of pointed out the problem recognition exercises that are in the ebook. These are fantastic to help you practice the differences between all of the different like symbols and see if you're doing them all correctly. So, and I also pulled out some with the absolute values because those are really important here too. So basically I think I'll start with the left. We'll do the left column first, and then we'll do the right column. And this is just all about, can you know, are you paying attention to those symbols? Because the symbols, or wait a minute, I think this is supposed to not have that minus because now that's the same thing as the top one. I think I actually put a negative when it shouldn't have been there. Or maybe that was supposed to be a minus sign. That was probably supposed to be a subtraction sign. So we'll just make that we'll kind of make that a subtraction sign so that it's different. Must I just typed the wrong thing when I was doing this? Okay. So here's also a good way to show your work is, okay, so here's, let me go into Sorry, guys. I seem to have gotten kicked out. Let me go back. Hopefully it's still recording. Okay, it's still doing that. I don't know what happened there. Let me share my screen again. Okay. So, what I was saying is half the battle to learning algebra is making sure that you are taking good notes, effective notes that are actually useful to you on quizzes and exams. You know, I've been teaching this class a long time, and I've talked to many students, and I've had students who have taken the class and then they had to repeat it. And those that did better the second time, like, told me what they needed to do was change how they were taking notes because it wasn't effective. And once they started taking better notes, they found that they were actually able to understand the material better. So really, that's what we need, is you need to make sure your notes are useful, because if they're not useful, then you're not really learning from them. So when you take notes, like if you're taking problems, either you're reading from the textbook or from a live session like this, or you know, if you're doing the homework problems, you should always write down the directions. And the directions are the words, not just the numbers and the symbols. So you don't want to just write down the numbers and symbols, because then you're missing the directions that are telling you what you're supposed to be doing. So for example, here, the directions would say to simplify. So simplify is a very common direction that we use to basically tell us to make it as small as possible. It often involves doing the order of operations. So you need to write down those directions, because that word tells you what you need to do. So when you're going on later and like you're doing other homework problems and you're trying to find something similar, you need to pay attention, because they may look similar, but the directions are different. So you need to pay attention to those directions. And they're giving you a hint. Where do you go next? What do you need to do? So it's really important to write those down. Now, the second thing about writing down when you're taking notes is to always work vertically, because a lot of math that we do, especially when we solve equations, has to be done vertically. So don't go left to right, go up to down, you know, top to bottom. And if you're worried about using a lot of paper, you can fold your paper in half, and then you can put, you know, you can use 2 columns basically to take your notes. So you always want to go top to bottom. And then the other thing that is very helpful is I give a lot of directions that I say verbally, and you'll see that in videos. You don't want to write down only the math that's going on. You want to also write down the directions that you're being told. Like, are you being told to add? Or are you being told to subtract? Or all of those things. You should write those down as well, because those are also directions, so you can see the patterns that develop. Because math really is just following rules, and to follow the rules, you need to see the patterns and when you use the rules and when you don't. And it's hard to learn those if you don't write them down. So I will not be writing those down because I'm saying it verbally, but you should be writing that down. That way you can, those patterns, those rules can start popping up to you, and then you can start internalizing them, and then you actually have notes that are useful because they're telling you what the rules are that you're supposed to follow. So I'm going to start on the left column, going top to bottom. So our first problem is -8 plus -4. So we're simplify, which basically means we just want to do the math here, do the order of operations. So we want to add. So our rule is, when you've got the same sign and you're adding, you add the numbers and then they have the sign that you began with. So we would have 8 plus 4, which is 12. And then because they're both negative, our answer is negative. So this is equal to -12. So I didn't write down what I did in my head, but that's something that you would want to write down in your notes. So I'll just kind of show you something that you might want to write down and say, okay, first do 8 plus 4, and then you might say answer -12. because originals were negative or something like that. So you want to write notes to yourself explaining how you got that answer. So we did 8 plus 4, and then we made it negative because those original numbers were negative. So that's how you should be taking your notes, because that gives you something to follow later on when you're looking at other examples. So next problem, I have -8 times -4. So if it's in parentheses, there's no symbol between the -8 and the -4. We call that implied multiplication. If there's not a plus, a minus, or division, then it's automatically going to be multiplication. So we multiply 8 times 4, which is 32, and then 2 negatives make a positive, so this is going to give us a positive 32. So again, you might want to write down what you're doing, that you did 8 times 4, and then it's positive because 2 negatives multiplied are equal positive. So you'd be kind of writing that down in words. And the nice thing about these being recorded is that you can do that later on. You know, you can pause the video, you can rewatch it, or like make a note to yourself and say, okay, go back to this point in the video, rewatch it to get those directions or something like that. Now, the third one here in the first column that I have I corrected, let's do -8 minus -4. So when we're subtracting a negative, that becomes a positive. So this is the same as -8 plus 4. So I have to actually write that down first so I can make sure that I can see it properly so I know what I'm doing. So now what we're really doing is -8 plus 4. So because we have opposite signs, you do 8 minus 4, which is 4. And then because the 8, the larger number is negative, our answer is negative, so we get a -4. And sometimes, if I have multi-step problems, I'll box it just so that I know that's my final answer there. If I just have like one that I just completely did in my head, like the top 2, where I didn't have to show any extra work there, then I won't. But that's just something that I do so that I can indicate that that was the final answer. And then the last one, we have a -8 divided by -4. So first you just divide the numbers. 8 divided by 4 is 2. And then they're 2 negatives, so that gives you a positive answer because they cancel out. So we get a positive 2. So let's move to the right side now. We'll do the second column. And we'll work from the top. So we have 12 plus -2. So they have opposite signs. So we subtract 12 minus 2, which is 10. And 12 is positive. The bigger number is positive, so our answer is positive. So that's a positive 10. The next one, we have 12 minus -2. So we're subtracting a negative, so that becomes addition. So that is the same as 12 plus 2. So then we can add those, and we get 14. And in this case, I decided to circle it versus boxing it, whatever works. Third one, 12 times -2. So you do 12 times 2, which is 24. And then because there's one negative sign, our answer is going to be negative. So this will be a -24. And then the last one, we have 12 divided by -2. So first just do 12 divided by 2, which is 6. And then one negative sign means a negative answer, so this will be -6. Are there any questions?
That one that was the -8 minus the -4, if you're just going to subtract it, why change it to the addition instead of just subtracting it? Could you do that too?
Well, we didn't. So we subtracted, we did 8 minus 4, and then we put a negative sign in front because the -8 is larger. but that's different from -8 minus -4. Like these are two, they're not the same thing. Because 8 minus 4 would give you a positive 4. Here, so let me try to rewrite differently what we're doing. So if we have a -8 minus a -4, so we had, that's basically the same as -8 plus a -4. Basically, the way that we're thinking about this is that, well, -8 is bigger, so it's got the negative in front, and then we're doing basically 8 minus 4, or you can think of it's this 8 plus -4, which is the same as 8 minus 4, but we have a negative in front. So just doing subtraction like 8 minus 4 and then making it negative, it's to show it that work to do it that way is you'd have to do what I did in blue in order to show that. Because it's not just this, we can't just say -8 minus and then like leave off a negative sign or something like that. And what I did here in blue, I'm allowed to do because I basically did something called factoring that we'll learn about later. But I'm factoring out a negative sign, and that got me my 8 plus -4 in parentheses. Then I undid the rule of subtraction, which said that subtracting is adding a negative. I reversed it and turned it into subtraction there. So I did a few rules here to basically do the subtraction. But showing that work is harder, and so that's why we do -8 plus 4, and then it mentally in our head we think about, well, what does that mean? How do we do that addition when you have opposite signs, and you subtract them, and then you just pick the sign of whatever the bigger number had. So I'm basically giving you a mental shortcut to do it so that you don't have to show all of the steps in blue that I showed in order to do these steps. I don't know if that helped or answered your question.
Oh, that makes sense.
Okay.
It makes sense.
It's one of those things where, like, to really fully understand it, you need to take more math or at least get further in the class, so just accept it for now, and then it might make more sense later on. And you'll find that with a lot of the math is you'll learn these rules, but you don't learn why the rules work until you get deeper into math. So you just kind of, the one thing about math is don't try to overthink it. If this is the procedure that you do, just do it. If you try to think too much about why that works, you might not have the knowledge that you need at that time to understand it. So for a lot of you guys that don't have to take more math, I would just say just accept the rule for where it is and just say, well, I need to follow these rules. And then, you know, maybe by the end of the course, you might be in a better spot where you can say, well, why did we do that? And then we can kind of go a little deeper into it. Because there are some other, you know, there's these other tricks that we're doing, and I'm kind of, you learn the shortcuts because they're a lot easier to understand. And this kind of, if you think about, if anybody has kids and like what is called new math or the Common Core, basically, you know, we're taught to do multiplication much differently than what most people are taught, where we line things up and we, you know, we have to, or like even with subtraction and addition, we have these carrying and everything like that. When we were taught how to do all those rules, we weren't taught, well, why does it work? We just said, this is the rules, this is how you multiply them by hand, this is how you do all these things. And now the way of teaching with the Common Core is they're trying to kind of show why they work. But that's why it looks so different, and it's a lot harder for people to understand, because if you don't really understand the deeper math behind it, the why doesn't really make sense. So I think that's why people really struggle if you have young kids, because they're like, I don't know how to do this. It's because they're kind of teaching the why at the same time that they're teaching the how, but it's a less efficient process. So. Are there other questions? Okay. Next slide, and this is my last slide of examples. So we'll do the ones on the left, and then we'll do the ones involving the absolute value, because those are usually pretty tricky for people. So top left here, I'll go top to bottom. We have a negative 36 plus 9. So the way you do this mentally is that you just do 36 minus 9, which is 27. No. Yeah, wait. I'm like having a brain fart, so I'm yeah, 27. Okay. And then it's a negative in front because the 36 is negative. So our answer here is negative 27. Now, if you are wondering about that, why that works, what we're kind of doing, and again, we're essentially sort of factoring out a negative. So if you have any familiarity with factoring, so if you understand factoring, you know that, and that's something we'll cover in like a week or so. But when you factor out a negative, all the signs change. So that's how this works, is to do this trick of 36 minus 9. We're basically factoring out a negative so that we can do the subtraction and then putting a negative in front. But, you know, it's something that you haven't technically learned how to do yet. So we're just teaching you the steps. Do the subtraction, then whichever number is bigger, that's your answer there. So that's basically what you're learning here. Next one, we've got negative 36 times 9. So you do 36 times 9, which I definitely need a calculator for that one. And then because we have one negative sign, our answer is negative. So that is going to be negative 324. The next one, we have negative 36 divided by 9. So you do 36 divided by 9 first, which is 4. And then there's a single negative sign, so our answer is negative. So that's going to be a negative 4. And then we have a negative 36 minus 9. So since they're both negative, you need to basically do 36 plus 9, which I'm going to just use my calculator because my brain is failing me, 45. And then because they're both negative, this gives us a negative 45. Now, if you know factoring, essentially what we're doing is, again, factoring on a negative, and then that changes the signs, and that's how we get to the 45 and then the negative in front. But everything in blue is something that is called factoring. So I'll make a note. It's like the real mathematical steps that we're doing versus these mental shortcuts. And so that won't make any sense until we get to that part of the book, unless you've had some familiarity with it. So moving on to the second column now, we have these absolute values. And so this is usually where people get confused and start to really start getting things like putting negative signs in the wrong place and all that kind of stuff. So when you have these absolute value symbols, so these are solid straight lines, and so you need to make sure that you don't think they're parentheses, or you don't get them confused with parentheses. Anything inside, or any number inside an absolute value, becomes positive. So I have, for my first example, the absolute value of negative 6 plus the absolute value of 2. So your first step is to take the absolute value. So when you do the absolute value of negative 6, that becomes a positive 6. And then 2 is already positive. So when you take the absolute value, those symbols disappear because you've basically done that action. Then we just add 6 plus 2 is 8. Now it's very different when you have addition inside the absolute values, because if you have addition inside absolute values, you need addition first before you take the absolute value, because the absolute value only works when you have a single number. And so we have the absolute value of -6 plus 2, we have more than one number in there, so we can't do the absolute value yet. We have to do the -6 plus 2. So -6 plus 2 is a -4 because you basically have 6 minus 2 and then a negative in front because 6 is the bigger number. So that gives us absolute value of -4. Then you take the absolute value and make that positive. So your final answer is a +4. So it's really important that you have to simplify inside absolute values before you do the absolute value. And that's part of the order of operations where you have to simplify inside before you can work outside. So we got to simplify the inside there first. Now the next one we have here is absolute value of -6 minus the absolute value of -2. Now with absolute values, you can't distribute or you can't multiply through the absolute values. So that subtracting absolute value of -2, we can't cancel those negatives out because they're not parentheses, they're absolute values. So we have to do the absolute value first. So that absolute value of -6 becomes a positive. Then I have my minus sign. Then the absolute value of -2, that makes it a +2. So then we have here 6 minus 2, which gives us 4. And then the last example here, we have a -6 minus 2. So that's the same as -6 plus a -2. So you're basically adding the numbers, and then you're going to have a negative answer. So 6 plus 2 is 8. So that's going to give us -8 in the absolute value symbols. Then we take the absolute value, which makes it positive. And so our final answer is a +8. So what's important with these absolute value problems is the order that you do things. You simplify inside them first, then you take the absolute value, and then you continue simplifying afterwards. So you have to go in that order, and that's a good thing to write down in your notes. So simplify inside, then take the absolute value, and then simplify further. So those are basically the 3 steps that you do whenever you work with absolute values. So if you have things, added on the inside, you have to do those first. Now, if you don't have anything in the inside other than a single number, you can skip that step and move to the next step. But those are the 3 basic steps that you follow. Are there any questions? Okay, so that was what I planned on going over is basically to kind of cover those rules, especially with the negatives, because people do get confused with those. Now, when you're working with fractions, the same rules apply. So I didn't do any fractions here, but when you're working with fractions, the same rules apply. And I didn't do anything with exponents. But if you think of exponents as repeated multiplication, then the rules for multiplication apply for there as well. So basically what you'll find as we go through this course, that in the end, you'll always be following the order of operations in some aspect. And so getting those order of operations down will really help you, and that's really making sure that you've got your signs correct with your adding and subtracting, all those kind of things. Because if you can get this stuff down really well, that will make it easier, because we're going to be using the same rules over and over again. It's just going to be looking slightly different. But if you write down those steps like I suggested, you'll start to see the patterns, and then you'll start to say, oh, this is this type of problem, so this is what I do. And it's real, learning math successfully really is about recognizing the rules and the patterns and just being able to follow them. And a lot of that is being able to learn the symbols and know what those mean, and then learn the language, the definitions, and those words that are telling you what to do and what those mean. If you can, start to see the patterns and the symbols and identify this is this type of problem, this is this type of problem, it will help you go a long way. And one thing that will help you do that is before you take the quiz, do some of those optional assignments. You don't have to do every problem on those optional assignments, but those are designed to help you study and to give you lots of practice. Like there's way more practice problems than you need in those assignments, because I think there's like 40 in each one. So that's like 160 problems, like way more than you need, but there's enough there that you can say, oh, I don't need to practice this type, I know how to do it, but this type I do need more practice with. So those are there to help you practice and study so that you are prepared for the quiz. The homework is to help you learn it, but that's not, if you simply do the homework and you don't study, you will not be ready for the quiz, because the homework, that purpose is to help you learn the material, but it's the practice that helps you kind of really get it ingrained so you can take a quiz on it. That's what the optional is for. But we don't want to assign the optional because 160 problems are way too much for you guys to do. That's a lot. So that's why we make them optional, but it's up to you to spend the amount of time that you feel you need in order to really learn the material through those. So it's kind of up to you on how much time you spend studying those, but at least an hour doing those is recommended so that you can be ready for the quiz. And I sent out an email about this today just to make sure that everybody understands like the purpose of these things, because some people think, oh, I did the homework so I should get 100 on the quiz, but that's not exactly how it's designed. And that's because math is one of those things that you can only learn through practice. And so that's how you have to learn material, is you just have to do a lot of problems on your own. And we've picked some out to help you so that you don't just pick random problems you don't need to know, basically. So do you guys have questions on anything else about the class that I could answer right now, that are not necessarily about what I just covered, but just other things? Because I'm happy to answer some.